Alvarez, and this is my Physics 1. I'll go back. Physics 2 Lab 1. In this lab, we worked as a team trying to electrolyze add charge to tape particles and determine how much charge was on the tapes based on how a second piece of tape moved when they were brought close together. Some of the main formulas and principles that we kind of used and the laws that we used for this to work would be Newton's second law, and then the velocity update formula, gravitational force, electrical force, Coulomb's constant, and you can see those kind of written out there. And they were important definitely to the glow script, but also just kind of conceptually with the project that we were doing. A review of the experiment would be two pieces of tape with equal length were put on top of each other, and one of them was pulled off of it to add the charge. And we observed what happened when the tape was brought near, piece of plastic, our own hand. We were just kind of creating other pieces of tape to do this. And then one thing that we had to do was use new pieces of tape to charge, because sometimes it wouldn't recharge right. And yeah, we're just making a lot of observations, writing things down, writing down the different numbers that we were seeing. Main ideas would be two pieces of tape repelled each other when near. The tape was attracted to the hand in the plastic because probably they got polarized. Charges are assumed to be point charges at the center of tapes when we're actually doing the experiment, which is not really true in reality. Assuming both pieces of tape had the same charge as well, just talking about size and everything, and just how well we actually charged them. Data and conditions would be, we had about a 0.11 meter piece of tape. Tape mass was pretty small. It's not a very massive thing. The tape width was about 0.019 meters. And that's how we calculated an area to use in GlowScript, which, I don't know, we'll talk about that later and things that could have gone wrong. Here's my GlowScript code. You can see I put in the tape length and tape width and weight, and the different formulas, and also constants like the gravity and the distance and things like that. This glow script was pretty basic for the first lab, and it helped give us this little model on the right. There's just a point charge going up and down, and it also outputted the numbers that we wanted to use. Discussion for the top tape. Discussion questions. In conclusion, for the top tape labeled U to float, the net force acting on it had to be equal to 0, and that was assuming that the only forces acting on the tape are the force of gravity and the electric force, so they must be equal. And then source of error would be obviously the forces, because it's not in a vacuum, it can't really exactly be like that. And also measuring, the distance of the tape, that was very hard to do, and just kind of measuring the size of the tape. It started where we were it was difficult getting results, so we were pulling a bunch of different pieces of tape up and trying to charge them and try it. We were just trying to match the actual tape size, so those numbers could be a little bit off. And then there weren't necessarily uniform heights. We didn't know how much slack to put in it, and the hand might have affected the charge of the tape based on what we saw. And also just the tape's not a true point charge, which I kind of mentioned a little bit in the glow script. Questions would be just kind of considering what would happen if the positive charges and the protons and the electrons switched. If the electrons all became protons, it would be likely the same exact effect. But if they were opposites, they would attract. Why it's important to handle the charge tapes as little as possible. We do think our hands were kind of affecting things, and also just the tape randomly getting stuck to things, and the charges are easily transferred around. So that would be an important thing to think about if trying to do this in a much more controlled environment. But yeah, thank you.